All right. My name is Hongchan. I'm software engineer in Google Chrome team. And my primary project is a Blink rendering engine. And I'm the API owner of a WebAudio API in Chrome browser. So, thank you so much for having me here, Ben. So, I'm really excited about this presentation because this is literally first public appearance of AudioWorklet in screen. So, yeah. And before we start, I might ask some questions because I am not aware of your background at all. So how are you guys familiar with the web audio in general or?
In general.
In general, yes. Okay. So do you know what this audio worklet means? Okay. So today I'm going to talk about what the audio worklet is and why we need this and how to use it. So very simple, and pretty much it will be followed by some very simple demonstration, which are already on the GitHub. So let's start. So what is audio worklet? We know the term audio. Audio is really familiar because it's just sound we can hear. But the worklet, the term worklet is not something you usually hear, right? So the worklet itself is a very recent project from the web developers. I mean web browser implementers. So why don't we just start with that? So what is worklet? We have an animal pig, right? Pig has a baby pig. We call baby of a pig as a piglet, right? So worklet is actually slight, lightweight, smaller version of worker. You can just think of it that way. I think that's pretty much most intuitive explanation that I can give you. But in the specification, if I have to explain with the more dry and rigid languages, then it's going to be API for running scripts in stages of stage of the rendering pipeline, independent of the main JavaScript execution environment. It's very very jargon. But in this sentence, there are two key points that you might want to focus. The first one is the rendering pipeline. The other one is independent of the main execution context. What I mean by that is rendering pipelines usually involved with the audio and graphics. Your main thread in the browser don't do anything about that, right? So by using this worklet, you might be able to touch the graphic rendering engine thread or audio thread. So that's kind of it's more of a gateway API, basically allowing web developers to access those forbidden areas so far. Also, the second point, independent of the main JavaScript execution environment. That means it's going to give you standalone, isolated global scope, which your JavaScript code can be evaluated and loaded separately from the main JavaScript scope. Does it make sense? Yeah. Let me just go on. I think I can make it a little bit clearer than that. So this is what you have to do with this new worklet concept. You have a main execution context, which is just main browser's main thread. This is where you usually run your JavaScript code. But in this scope, you call worklet.add module. Then you provide a URL to this different, separate JavaScript file. Then this JavaScript file will get loaded and evaluated in the separate scope, which is green box on the right. And somehow, this scope runs on the rendering thread. It might be graphic thread, it might be graphic rendering thread, or it might be something called compositor thread in the browser, or it can be also web audio rendering thread. So far, there has been no way to access web audio rendering thread from your own JavaScript code. So, and worklet is just simply the name of an actual infrastructure. And there are several kinds of worklet. And the first one is actually paint worklet. This was I think in the Chrome browser, we recently tried to ship this feature by default. And the the main thing it tries to do is basically allowing you to define your own set of a CSS property. And we give you the ability to define a paint function with your own JavaScript code. So that's kind of very interesting. So you can define your own CSS property with your own JavaScript code in a separate JavaScript scope. So basically, you can draw whatever you want inside of a small canvas, and you can treat it as your own CSS property. That's how you can use PaintWorklet. You can Google it up. It's already out there. We are not shipping by default, but we have been experimenting this feature for a while, so it's out there. And today, I'm going to introduce the AudioWorklet, which is pretty much similar to PaintWorklet, but with this AudioWorklet, we allows web developers to write JavaScript code to process the audio with the sample accuracy. So that's something hasn't been really possible, like in the right way. But I'm going to get to that a little bit later. Oh, okay, you're smiling. That's a good sign. And also there's the other efforts like animation worklet, and also we have something called layout worklet, and that is not the topic of this topic, so I'm not going to talk about that like deeply. But so these two boxes on the left, on the right, in the dark gray color, actually they run on different thread. So if you look down there, I just marked it as a web audio render thread, and animation runs on the compositor thread. But PaintWorklet runs on the main thread, so that's a little bit different. But conceptually, the worklet is a thread agnostic. So returning back to the original question, what is the AudioWorklet? From my perspective, AudioWorklet is exposing the low-level audio processing capability to web developers within WebAudio's API ecosystem. So that's how I define this AudioWorklet. There has been a big discussion before the existence of WebAudio API. I think it's kind of a little bit of battle between Mozilla and Chrome, because Mozilla also had an idea of having this low-level audio API. I think that's something called the Audio Data API back in the day. But somehow WebAudio API survived, and that's what you guys are using today. But basically, what AudioWorklet does is we are kind of bringing this Audio Data API back to the WebAudio API's big picture. Let me continue. So we cannot bypass this question when we talk about AudioWorklet, because AudioWorklet is all about writing JavaScript for audio processing, to manipulate the audio stream by sample level. But we can already do that, right, with something called script processor node. Are you guys familiar with the script processor node? Script processor node is a type of audio node in the WebAudio API that has been there since day one. So it was a part of an original version of the WebAudio API, but our audio working group, who has been writing this audio API specification, they decided to deprecate this feature completely from the spec because it has some design flaw. I'm going to talk about that a little bit later. But basically, AudioWorklet is a proper replacement of the script processor node. Okay. So that's why I created stupid slide. This is a big elephant in the room because everybody literally has been complaining about script processor node because it glitches and it stresses down the main thread. It is really a bad combination. But we are trying to replace with the AudioWorklet, but the work has been taken too long, and a lot of people have been complaining about it. So that's why I'm also very excited about talk about this AudioWorklet today. So what is the problem of a script processor node? I think the most important problem is actually it is underspecified. So if you look at the specification document, the section for a script processor node is really short. That's usually a bad sign because there's a room for inconsistency across the browser. So as a web developer, if you just write some application with the script processor node, there might be a chance to see some unexpected behavior from different browser because it's not really well defined. there are some like room for inconsistency, and they usually turn out in very dramatically. So that's usually a very bad sign from the specification perspective. And also, script processor node does double buffering. That usually causes latency. So unlike the other native audio node, script processor node has an argument of a buffer size. So you can set your own buffer size for your node. And internally, in Chrome browser specifically, I'm not sure about what Firefox does, but in Chrome browser, we are actually creating two identical buffer and do the round robin to avoid data race. That usually increases the latency of the audio processing, and that's bad, right? And script processor node uses main thread to process the JavaScript code. That's also a really bad sign, because main thread is always busy. It needs to process UI, user interaction, it needs to lay out DOM, and it needs to do all the things, but you're kind of putting another task on top of everything. That also means this script processor node audio processing code has unlimited access to all the DOM elements in the page. And this event is actually getting called for every 3 milliseconds. So basically, now you have ability to touch all the DOM elements every 3 milliseconds. That's a bad idea, right? And like I said, the script processor node runs on the main thread. And the worst problem of all this is actually issue of data race. This is more of an implementation detail, so I'm not going to go into that like here, but you can ask me a question. I have some backup slide if you ask the question about that. But the symptom of this data race is you're going to get glitch, or some of your samples will be dropped out. And also you might be experiencing stuttering. So basically, you're going to hear some samples over and over again. So, but still, people can ask questions. Why is it that bad? I might hear some glitches, but it's not a big deal, right? And you're gonna see, I think you have seen a lot of web audio demos out there, and many of them actually has this script processor node inside. And depends on your system capability, you might hear some glitches or not. So it's very, I think it's really difficult to answer this question, but let me just show you why script processor node has this glitchy or latency problem. So this is what you have normally with the WebAudio API. So you write JavaScript code, create context, create node, make some connection. Now you have this graph. This is kind of conceptual graph of audio nodes, right? But internally, this is what WebAudio implementation does. So left side, you have a really nice, clean JavaScript code. On the right side, we create this under the hood component, interconnect to each other. These green boxes are actually the one who does all the magical things for you. All the audio processing happens on the green side, not the gray side. That's really important. That's really important thing to know. And when you have graph like this, we don't usually have a problem, because all the code on the right side is a C++ code, and it does all the audio processing in the native speed, so it's supposed to be super fast. So you're not going to hear any glitch in normal situation. But when script processor node gets into the picture, it becomes a very weird thing. Because like I said, script processor node does audio processing in the main thread, but all the green boxes lives on the audio rendering thread. So to process this piece of JavaScript code, actually you have to make the jump from the audio thread to the main thread. In there, actually you're sacrificing some speed, because this is not like synchronous processing. It's an asynchronous event handling mechanism. Basically, I'm going to throw this task to the main thread, and you can process it whenever you can, type of idea. So it's not going to immediate. That means latency. So that's kind of biggest problem of a script processor node. And like I said, I have some backup slides for more technical issues around the script processing node. So if you're really interested in, I can discuss that with you. But here's a real question. So I said AudioWorklet is a proper replacement of a script processing node. That means when we have AudioWorklet node, script processing node will be removed from the implementation. So a lot of people are actually asking this question because their application depends on this. So script processing node is really going away. So my answer is practically actually no, because it's been there for like 5 years. A lot of web apps depends on it, so we cannot just like kill it like instantly. So we're gonna, if we have to remove this for some security reason, because it has like a small security loophole. So if we have to remove this from the implementation, we're gonna give you a heads up, also warning like ahead of time, so you can actually prepare for it. So next question is then how this AudioWorklet node is better. This is how AudioWorklet works. So the biggest difference in its implementation is with AudioWorklet, actually V8 engine, the JavaScript engine is running on the audio rendering thread. This hasn't been the case for the last 5 years. So this is kind of the biggest breakthrough, if you will, in the web audio world. So now we have a fully capable JavaScript engine running on the audio rendering side. Actually, we don't need to make the jump at all. We can do all the JavaScript processing in that thread immediately in the synchronous and sequential manner. Does that make sense? So we don't have to make the jump. That means we are fast. So what's the other benefits? If you look at the specification, actually, the text in the specification of AudioWorklet is big, actually. So if you just the sheer amount of the text is really, really big compared to the script processing node. So that's usually a good sign because we discussed a lot. This discussion took about an year, I would say. So over a year without implementation, we just talked about it. It looks very, it looks very lazy and boring, but I think it's a very necessary process. That's also, this is why now we have a more well-defined behavior of AudioWorklet. It's like less room for the inconsistency across the browser, so you can actually trust it. Like I said, JavaScript engine is now running on the audio rendering thread. That means your JavaScript code just runs as a first-class citizen. So we don't treat JavaScript code as some weird jump of code from the web audio. Now, if you write a JavaScript code for an AudioWorklet node, it's going to be treated just like a native audio node. That's a good thing, too. And this next step is really interesting because you know all the audio primes, right? Audio primes is a part of audio node. Like gain node has a gain audio prime. Bi-quad filter node has a frequency audio prime. But what if you want to have your own audio prime? That has not been possible at all, even with the script processing node. But AudioWorklet actually gives you the ability to do that. So you can define your own audio prime object, and web audio system will create an audio prime object for you. Then you can use it as just normally as you use that. So you can call automation method. You can set the value, and we're gonna see that in the example later. Like I said, the AudioWorklet code runs on the web audio render thread. Also, extensibility is a big issue for the web audio. Actually, the technical, technical architecture group is a part of a W3C, and they reviewed our WebAudio API specification and pointed out all the audio node does not have proper extensibility. That's an issue because it's kind of very discouraging web developers to do something interesting. We have some class, then you need to be able to subclass or extend from it, so you can build your own features out of it, right? And AudioWorklet actually based on that exactly the same idea. So we give you the AudioWorklet node class, AudioWorklet processor class, and you can subclass or extend it as you want it. And so on. There are many benefits, but these 5 points are that I think really important. So let's move on to the how part. So how do I use it? Now we have these 4 new terms. Is this becoming boring or so far so good? Okay. Okay. So first one is AudioWorklet. AudioWorklet is a singleton object, belongs to window. And AudioWorklet global scope. This is the scope for the JavaScript code that will be evaluated in like a separate scope. And we have AudioWorklet node and AudioWorklet processor. So this is the code. So AudioWorklet.add module. That's the first call you will make if you want to use AudioWorklet. And this .add module function usually takes an argument of a path or URL, or you can even use a URL object. And on the right side, you have a different file, a separate file that's called bypass.js. In this JS file, you just simply define your own subclass of AudioWorklet processor. So let's go through one by one. This gets called, then this whole thing will be evaluated. And in this scope, this is a separate scope from the main scope, so they don't really do interfere. So now we have AudioWorklet processor, and you do extend. And this bypass is the name of custom class that you are trying to make. And in this class definition, you have a constructor, and more importantly, you're going to have a process method. This is the combination of AudioWorklet. So in that process method, basically you do DSP processing there. And if you look at the left side, this add module function returns the value of a promise. And when this promise gets resolved, then you can create the AudioWorklet node that you just defined by the right side of code. This AudioWorklet node is literally just a subclass of audio node. So it just acts like audio node. That means you can interconnect with the other native audio node as well. So now you have a context, you have an oscillator node, and oscillator node is being connected to bypass node, and this bypass node is going to the destination node. They just work like audio node. So let's look at this process method. This is how you use this process method. The argument of this process method is inputs and outputs. Audio node can have multiple inputs and outputs, so we just added like S for the plural. Basically, the first 2 lines of this method is trying to get the first input and first output. Usually, audio node has 1 input and 1 output. I think the only exceptions are channel splitter node and channel merger node, because we wanted to be able to recreate the functionality of a channel merger or channel splitter with the AudioWorklet node. So we decided to allow these multiple inputs and output. That actually made it this design a little bit more complicated, but I think we are kind of very happy about that. So first input and first output, inside of that input, we have multiple channels, right? So this is how you're handling multiple channels. So if you query that input.length will give you the number of channels in that input, then you can iterate those channels inside of the input. And what's happening here is basically I'm getting the channel of the input and basically doing the mem set to the output buffer. This is what I call bypass. Right? This is the most efficient way of using this flow territory method .set. Like I said, these inputs and outputs can get a little bit complicated because in the specification, it reads like a sequence of flow territory array. I think the WebAudio API is the only one is using this type of notation. So this is how these inputs and outputs they work, right? So you can have multiple inputs, and each input can have multiple channels. Let's say you want to access like the first input and third channel. And this is how you address, how you access those channel stream. Same thing with output. If you want to access the second output and the first channel, you pass this. You access those channels like this. So this is just illustration. And also, like I said, AudioWorklet supports native audio param. This is really neat stuff. So when I made first working prototype of a AudioWorklet with the audio param, I really hooray. Because being able to use this audio param data, which is calculated by WebAudio system, I don't have to do anything. If you just call linear ramp, exponential ramp, WebAudio engine will do that for you. You just get the data and use the data in the process method. So how do you define this process, the audio param? Here's what you do. You have to define static getter called parameter descriptors. And then this getter basically returns a set of a collection of definition of audio param. So basically, in this getter, I'm returning just one item. The name is gain as a string, and default value is 0, but also you can define minimum and maximum value, just like audio param. And if you see here, this is kind of interesting, right? You just created an AudioWorklet node named bypass. And now you have a bypass AudioWorklet node. But this bypass audio node has audio param named gain. So how do you access it? All the AudioWorklet node will have this parameters getter. This parameters getter returns ES6 map object. And how to query this ES6 map object is simply get. And you use a get function with the string that gain. Here I'm using gain. Then it will give you the audio param object, which is created by this getter. Does it make sense? Yep. Then like I said, this gain param is just audio param object, so you can do things like this. Gain param.value 1. Gain param.linear ramp to value 0, 5. And also here, in the process method, it'll give you the system will give you the parameters data. This is how it works. So AudioWorklet processor has 3 arguments: input, output, and parameters. In parameters, that's just a JavaScript object, so you can just treat it as an associative array. So, and query item will be a string that you just define for the audio param name. And like I said, all the audio param processing is done by WebAudio. So you don't have to do like linear ramping or modulation by yourself. You just plug in, and WebAudio system will give you the float32 array of value that are pre-calculated by audio system. That's a pretty neat thing. So let's see it. This is a kind of a emulation of a gain node, because we just created gain audio param. So process method has 3 arguments: inputs, outputs, and parameters. And you have, I'm querying the first input and first output. Also, I'm getting the float32 array value, parameters, gain. Now these gain values have a float32 array of a length of 128, which is a random quantum of web audio. So what I'm doing is I think this line is the most important thing. Basically, I'm multiplying input channel by the gain value and putting it to the output channel. This is what's happening in our gain node. So now you can recreate the gain node functionality with the AudioWorklet node just like this. This is also interesting stuff. I haven't talked about it in our benefit slide, but AudioWorklet will have a message port, but currently we don't have this feature in the Canary version yet. I'm working on this. So idea is we're gonna give the ability of bidirectional communication between AudioWorklet node, AudioWorklet processor. It is necessary because we need to talk to each other, right? For example, let's say I just built really nice fancy compressor for AudioWorklet node. And my AudioWorklet node compressor supports 2 types of mode. soft knee, hard knee. That's very usual setup for the compressor, right? But if you want to change this type of compression dynamically on the runtime, how do you do it? You can just think of it as an oscillator node. Oscillator nodes support multiple waveform, right? Sawtooth, sine, square. And how do you change those waveform type? Oscillator dot type, then you pass the string, like sawtooth or sine. That's what you can do with the AudioWorklet node as well. So you can set up a setter like type for my own fancy this compressor. Then eventually this setter will be just a thin wrapper around the message port. And message port will send the message to the AudioWorklet processor. It do its stuff on the other side. And also we have another example like audio buffer source node. Audio buffer source node has a start and stop method, right? It's a very popular method, right, if you will. You can do the same thing too. My source.start node, and basically this start node is a thin wrapper around message port. You can send the message to the AudioWorklet processor, and AudioWorklet processor does actual starting, stopping, and everything. And the other side, what you can do is, this is kind of a very interesting area too, because now you can use WebAssembly in this AudioWorklet global scope. It's basically just worker. The scope itself is really similar to worker scope, so you can use almost the same thing with the workers. That means you can use WebAssembly too. In WebAssembly, someone just implemented really nice FFT feature. I want to use that. So I just put those FFT function call, WASM function call inside of my process method. I process FFT for the incoming audio stream. Now I get the result. How do I send this analysis result to the main thread with the message port? So asynchronously, it will send the analysis data. And on the main thread, you can visualize those analysis data with Canvas or some fancy graphing framework, if you will. Same thing with the onEnded too. Audio buffer source net has an event handler called onEnded. That means you start some buffer source node, and when it ends, actually it fires back some signal so you can do something with those events. We can do the similar thing with the AudioWorklet processor. Because now you have full control over the audio stream. You know exactly when your node is finished, right? Then you can just fire back the event to the main thread. I'm done. Then you do some subsequent process after that. Interesting thing, but still not there, so I'm sorry about that. So this is how you define and use a port. So dummy node.port, this port is a message port object. You can define onMessage event handler. Also, you can send message by port.post messaging. It's really simple. The other side is also same as well. The AudioWorklet processor has port object, and it has post message and on message event handler. Okay. Current time. Maybe I think I should skip this, but I will just briefly just cover it. So current time is a property from the audio context, right? So audio context has a ability to query the actual current time in the audio rendering thread. Then based on this number, you schedule some event in the future. That's how this web audio system works. But this current time is slightly late, because if you query current time, basically web audio system will give you the last timestamp of a random quantum. And when you get those number in the main thread, like I said, it's asynchronous, right? It's not a synchronous event. So when you get those timestamp number, the actually timestamp has already passed. It's already stale. But why this is happening? Because this is async, right? You're getting the timestamp from the audio thread, then you're passing back data into the main thread. Now the data is stale. That's kind of a very usual setup. But in the AudioWorklet processor, in the process method, when you query the current time, is actual current time. It's actual like timestamp of first sample of your random quantum. So you can do something about it more accurately. So AudioWorklet global scope has a current time, which is a global property. You can query it like that here. So I'm basically caching current time into this dot created at. Basically, I'm caching the construction time on some class variable. And later, I'm doing something like this. So I query current time again. I subtract this created at number. That means it's kind of elapsed time from the node construction. So if this node is created and has been running for 5 seconds, do something. And timestamp here is pretty much like sample accurate. So this is a really important question. So can I use it now? Yes. It's experimental in Chrome Canary. So basically, anything after M64, milestone 64, you can use this feature. But the thing is, it's not enabled by default. So you have to go through a little bit of hoops here. I recommend this option here. Basically, what you can do is -- enable -- blink -- features worklet, AudioWorklet. You can just make a script and do whatever you want. And in OS X, the command line option would look like this. Okay? And the other option is a slightly more dangerous option, but it's much easier and accessible. You can use flag page. So Chrome / flags. If you go there, you can just look up for web platform features, and it will show you the item at the bottom. Then press enable button and restart the browser. There's one drawback. If you enable this feature, you're basically enabling all the experimental features in Chrome browser. So it might be more crash prone. And if you file a bug, my browser is crashing, and the problem is we don't know what caused it because you're basically using all the experimental features. So that's why I prefer the first option. So if you're using this first option, if system crashes, then you can blame me. You can just file a bug against me, and I will take a look at it. But if you do something like this, it's really hard to say, right? So let's look at the demo real quick. So we already set up a web page here. This is the address. Also, I'm going to share the slides that I just showed you today. So there's a link to as well. It's Google Chrome Labs.github.io and WebAudio samples and AudioWorklet. That will give you this page. And we have a brief description of how to use this feature in Chrome Canary too. And let's click this one. Yes. It's very boring. Just sine wave, basically all the code that you have seen in the slide. So let's look at the code. Worklet processor. Right? It's exactly the code that you have seen in the slide. And here's what's happening. There's a bit of text because we have some link there, but this is what's happening here. So for the first step, I did add module and loading the JavaScript code, and the loading of script code is finished. Then I create context, oscillator, AudioWorklet node, and doing some bypassing work there. Very simple. And let's go back to this one. There are some modulation going on. Let's look at the code. Yeah, I try to make comments as much as possible, so try to be informative here. But the basic thing is, I'm loading this noise-generated.js file and do the same, almost same stuff. Oscillator, gain node, AudioWorklet node, and make some connection noise generator is being connected to destination. So basically, so what's happening here is a very simple modulation. Okay. Thank you. So noise generator, it has one audio prime, and this is going to destination. Also, I'm creating oscillator with the gain node, and this is going to here. And I believe this audio prime is something named amplitude, right? Yes, amplitude. So what I'm doing here is I'm modulating this audio prime, amplitude audio prime with the oscillator, low frequency oscillator modulation on noise generator. It's a very simple thing, but yeah. So creation of a AudioWorklet node noise generator is also very simple. I am not trying to be fancy here because there are so many, so deep, profound algorithms to create noise. But in here, I'm just using the math.random function. So because this is just for the demonstrational purpose, right? So simple. This is it. And this amplitude here is I am querying from the parameters, which is audio prime data. And audio prime is defined like this. Does it make sense? Yep. And how about this one? This time I'm going to look at the code first, actually. So this is what's happening in the main thread side. Audio context, oscillator node, AudioWorklet node, and I intentionally set the frequency of oscillator kind of really high, 5,000. And also, I want to have a lot of like overtones, so that's why I chose a sawtooth. So oscillator goes into the bit crusher and goes into the destination. Also, I'm getting two audio prime objects like this, ES6 map getter, bit depth and frequency reduction, which will be two audio prime objects in bit crusher. And I'm doing some automation, set value at time, linear ramp, exponential ramp, and oscillator runs for 8 seconds. And let's go back to the AudioWorklet processor code. I'm defining two audio prime. One is bit depth here, and the other one is frequency reduction. And this code is actually from the specification. So we have example section for the AudioWorklet in the spec. I just copied and pasted it. So this is a textbook example. And let's see how it runs. Yee. Let's make some noise. This is also really simple example because we have a bipod filter in our WebAudio API as a native audio node, but that's basically what should I say, two-pole filter. So I always wanted to have more simple filter without any like distraction, just one frequency property, which is one-pole filter, really simple. Also has one audio prime object, frequency, and frequency gets automated like this. And one-pole filter implementation is quite actually simple. And here are some methods for calculating coefficient for a filter. Then we update coefficient for like every, this is K rate we call. So every random quantum, we calculate the coefficient and update the filter accordingly. Then we do the audio processing here. So let me close this out and try this out. Should be really simple. That's it. If I change this configuration with the continuous modulation with like a oscillator and gain node, then you're gonna hear more of like a wave sound. So these are demos for AudioWorklet so far, but I'm building more. I'm pretty sure a lot of people will come up with a better demo than me. So I'm really looking forward to that. So let's go back to the slide. Where do I have that? Okay. So I guess the next question here is, where do we go from here? There are so many possibilities, I will already tell you, but these are what's happening like right now or in the near future. The first one is WASM, the WebAssembly code, using WebAssembly in the scope of AudioWorklet. That work has been, like, a lot of people are making some progress there, actually. Are you familiar with the computer programming language called Faust?
Yeah.
Yep. Faust folks has been working on this really hard, and they are really pushing the limit. So,
For those who aren't familiar, can you explain what Faust is?
yeah, sure. Yeah, Faust is very domain-specific computer language. It's just solely focused on digital signal processing. Its syntax is really interesting, so you might want to take a look at it. But what they have been focusing is actually they try to use this LLVM to compile this Faust code to the C++ code and compile that into the JavaScript code with mscript, and you do the WASM. Those type of tool chain, these guys are really good. So, and they just, I think his name is Stefan. Stefan just sent me a link to their recent work on this WASM and AudioWorklet, and it runs actually okay. So I was quite surprised with it. And the other interesting possibility is actually using shared array buffer with AudioWorklet, because AudioWorklet gives you the low-level sample ability, low-level audio processing ability, because it's just a escape hatch for your audio application. You can actually ditch all the WebAudio API building blocks. You can just build everything in your own world in the AudioWorklet node. That's not recommended use case, but you can certainly do that. So there are some game engine developers. They've been working on the idea of porting game audio engine like AppMod, Wise, and compile whole thing into the WASM and runs on the web worker, and web worker can share this array buffer with the AudioWorklet. It's going to be really fast, one-directional communication from web worker to AudioWorklet, so basically you can run your own game audio engine. But this is just all the theory. Nothing has been done yet. And also interesting part is now we have a quite capable extensibility throughout the AudioWorklet node and AudioWorklet processor. You can package your own setup, your own custom code, audio code with the node module or the other package framework, then distribute it and share it with other people really easily. And dynamic code generation, I thought a lot of people would really, I didn't think this was really interesting enough, but a lot of folks in WebAudio Slack channel actually came up with this idea. Basically, server side, server can generate the JavaScript code on the fly, and based on the user interaction, you can create a different set of AudioWorklet process definition and send it to the client, and client parse those and integrate in your WebAudio application on the fly. That's also possible too. It's a crazy idea, but it's super interesting. And so on, so many things. So that's all I have for today, and thank you so much for listening, and I think the floor is open for the discussion or question. Sure. Thank you.